this is an electronic load with constant current feature. Well, what does it do? It acts like a fake load whose current can be varied, and the current is constant regardless of the voltage change at the input too. Why is it useful, you might ask? Well, you could discharge batteries and calculate their capacities by using milliamp hour formula, or maybe test your other power sources of their maximum current ratings, and so on and so forth. So this right here can carry a power of up to 40 watts. So the components over here which I'm using is an LM358 dual op-amp IC, two IRFZ44N MOSFETs, and few discrete components such as potentiometer and connectors. So right now I've connected a 10,000 mAh battery in series with an ammeter or a multimeter. So this is the knob which I'm going to vary the current at the multimeter. So let's watch together. As I slowly increase the potentiometer's knob, you see that it's like something around 1 amps. And now I'll crank it up to 2, and if I don't touch it, it will be around the same. And even if this battery voltage drops, the current consumption will be the same, since the op-amp continuously checks the shunt resistor and recalibrates the output current. So now I'll crank it up to 3 amps. Oh shit, 7 that is. Yes, 3, 4, 5, 6, 7, and that's the maximum of the battery, and holy shit, it's heating up. The wire of the multimeter is heating. I'll crank it up fully and it's 7.6. Now lower it and it's 0. For 1 or 2 amps it should be slightly varied. Something like this. And here's the explanation. So this right here is the operational amplifier which I'm using, which is LM358. Its non-inverting terminal input is connected to a voltage divider circuit. In this case I am using a potentiometer for ease of use, and the second pin, that is the inverting terminal, goes through a shunt resistor which is of 0.1 ohms, which measures the voltage drop across the resistor and ground. And also note that the loads negative or the ground, and the power supply for the op-amp ground is common here. If it's not commoned out, it will never work. The loads positive is going through the drain of these both MOSFETs right here, and yes, these both MOSFETs are in parallel. So the load current goes through the drain and comes out of source, which then goes through this shunt resistor and so on. So when the current goes through this, it creates a voltage drop right here, and that voltage drop is fed as input to the non-inverting terminal of this op-amp. Based on the potentiometer's position right here, it changes the output voltage at the gate, which turns in such a way that it resists more or conducts more based on the potentiometer right here. When you increase the knob of the potentiometer, the voltage or the output of this op-amp will get increased. Also note that the MOSFET I am using here is not a logic level MOSFET, so the output varies like around 4 to 12 volts on a 12 volt input. So when that happens, the gate is partially open or fully open or not at all open based on the potentiometer's position. When that happens, the resistance inside the MOSFET increases or decreases, which in turn reduces the current or increases the current basically. I've also connected a orange LED to the output and ground. So that's all for this explanation. A suitable or bigger heatsink than this is encouraged to use, since it heats up a lot, especially when you connect a very large load such as 5 amps at 12 volts or something like that. I don't know how good my soldering job is, but this circuit works pretty fine. What do you think about my circuit? If you liked it, then do share your opinion in my comments, or maybe negative ones too. I'll improve it in my future. That's it for today. Thanks. Bye.